So welcome to all of you. Today we'll see how to find the coordinates of a point in a space. Suppose your point P is in space. Suppose your point P is here. So this is not P. So this is x coordinate, y coordinate and z coordinate. Okay. So for that what we do? We have taken the three mutual perpendicular axes. This is what OX prime. So that is what x prime OX. This is the x axis. OX is the positive x axis. OX prime is the negative x axis. This is y prime OY. This is the y axis, right? And this is what? So OY is the positive y axis. OY prime is the negative y axis. This Z prime. This is your z axis. OZ is the positive z axis, and OZ prime is the positive is the negative z axis. Okay. So on these three axes, this is what? This is x axis. Actually, this is the perpendicular to the board. Actually, this OX is the perpendicular to the board. This is the three-dimensional figure. Okay. So now, so for this, so we have, due to these three axes, divide the space in 8 parts. So each part is called octant. Each part is called octant. So it divides 8 parts in a space. Okay. So these three mutually axes divide the space in 8 parts. And 8 parts, so each part is called octant. The first part is what? The first part is O, X, Y, Z. This is called first octant. Here what? Your X, your Y and your Z. Okay. So before that, we will see how to find the coordinates of a point. Okay. So the same thing here. For the plane, what you are doing? Suppose this is your P. For the plane, this is your x-axis, this is your y-axis, right? So for plane, what you are doing, if you want to find the x coordinate, you are drawing this is perpendicular to x-axis, and this number, whatever this number x, suppose it represents as x, represents as a number on x-axis, so then that will be your x coordinate. Okay. So to find a y coordinate, what you have to do? We have to draw perpendicular to y-axis, and this point represent y on y-axis, so that will be your y coordinate. Or simply distance from y-axis is nothing but the x coordinate. Distance from y-axis, this is what x. Okay, this distance is x. So distance from perpendicular distance of a point P from y-axis is nothing but x coordinate, and perpendicular distance of a P from x-axis is nothing but this distance is your y. This distance is y, and this distance is x. This distance is x. This distance is y. Right? So perpendicular distance from x-axis is nothing but the y coordinate, and perpendicular distance from x-axis is nothing but the y coordinate, and perpendicular distance from y-axis is nothing but the x coordinate of the point. So same thing here now. Same thing here. So if you want to find P, the coordinates of P, so what we do? We draw perpendicular to x-axis, y-axis, perpendicular to z-axis, and perpendicular to x-axis. Okay. Now this number represents x. Now this number represents y. This number represents z on x-axis. So these are the x. So similarly, so what here in the form of the plane? So what is this? This is OZY. OZY. So now this is what ZY. Okay. So this is what here the point. This is what this plane. Okay. So a plane which contains OZ and OY is called YZ plane. It's called a YZ plane. So a plane which contains your x-axis and z-axis is called XZ plane. It's called a XZ plane. And a plane which contains x-axis and z-axis is called XZ plane. X-axis and y-axis it is called XY plane, and y-axis and z-axis it is called YZ plane. Okay. So these are three planes: OXY, OYZ, OXZ. Okay. So this is simply the XY plane. XY plane. This is YZ plane. This is YZ plane, and this is what? XZ plane. That means a plane. A plane. Okay. So see, if you consider this plane here, so is there any plane? Yes, this is a perpendicular. Okay. Okay. So see, if you take this plane, so this plane is what? Suppose this is your x-axis. So now this plane is passing through x-axis and y-axis. So this plane is what? XY plane. Whatever the plane is XY plane. Now if you consider the plane passing through this, so that is passing. This is your x-axis. So this is what is passing through the x-axis and z-axis. So this is what? XZ plane. This plane is what? XZ plane. Now this is your y-axis. So and this is your z-axis. So that means what here, which plane you have to take? So that it contains the y and z axis. Okay. So that will be your this plane. Okay. So this plane on the wall. Okay. So which is parallel to the board. So this plane is what? YZ plane, because this plane passing to the y axis and z axis. So this is YZ plane. Okay. So on x axis your p is what? x0 0. On y axis p is 0 y 0. On z axis p is 0 0 z. So that means your point is on z axis, then this is. If your point is, if p is on xy plane, on xy plane. So now play xy plane. It is on the xy plane. Okay. So if you draw perpendicular to z axis, so we get a 0. We get a point 0 here. So on xy plane, if p is on xy plane, then p is of the form xy 0. Then p is p xy. Then p is of the form. Okay. Then p is of the form xpxy 0. Okay. So if p is on xz plane, so which is xz plane? This is your x-axis, right? And this is z-axis. So that is what? This is a plane which is perpendicular to board, that is passing through x-axis and z-axis. So if you draw perpendicular to the y-axis, right? So you get a 0 now. It is intersect to 0. So then p is of the form x0 z x0. That means y coordinate of p is 0. Okay. So if p is on xy, so yz plane, then yz plane is, this is a plane. This plane is yz plane. Okay, whatever the board is there, so yz plane, because this plane is passing through z axis and y axis. Okay. So now here what? If you draw perpendicular to x axis here, if you draw perpendicular, this is the x axis now here. Okay, this is your x axis. So the x axis is perpendicular to yz plane. X axis is perpendicular to yz plane. So now if you draw perpendicular to the x axis, okay, then it is a 0 then. Okay, then p is of the form p 0 y z. That means its x coordinate is 0. Okay. So now that if a line is perpendicular to this, if a line is perpendicular to any plane, so then suppose this is a line now. This is line in the plane and this line is perpendicular to it. So any point on this plane, any line on this plane is also perpendicular to that one. That means if your OX axis is a perpendicular this all, so your all is what? YZ plane. So then every line in this plane, any line, this is a perpendicular to x axis now. You can check this. It is a perpendicular to x axis. Any line on the wall is perpendicular to this x axis. Okay. So that means what? Any line in the plane YZ, in the YZ plane is perpendicular to x axis. Any line in the plane XY plane, any line in the plane XY which is perpendicular to Z axis. Any line, if you take any line from the plane XY, then it is perpendicular to z axis. So here also any line in the plane xz plane, any line in the plane xz plane, so that is perpendicular to y axis. So therefore the y coordinate is 0 here. Okay, so in this way you can obtain the coordinates of the points now. So due to this, okay, so now see, this is the perpendicular this, so this is section 1, section 2, opposite of that one section, so for above there are 4 parts. Okay, so which are the 4 parts? So suppose this is O, X, Y. O, X, Y, Z. O, X, Y, Z. So this is X axis, Y and Z. We will see only the which is positive and this. You know that. So here what? This is in the first quadrant. Your X coordinate and Y coordinates are positive here. Okay. Now if you consider this O, X, Y, Z. So this is what? This is positive. This is positive. This is positive. Right. So this X, Y, Z is this plane. So now here what? If you do here, okay, opposite of that one. So what you get here? Opposite of that is what? O, X prime, Y, Z. So this is what? Minus, plus, plus. Okay. And opposite of this one, then opposite of this one and this one, then opposite of this one, then what? O, X, Y prime, Z. This is the above the X, above the Y axis now. This is the above the, not above the Y axis. Yes, above the Y axis. Okay, above the Y axis. This is what? Plus, minus, plus. Then this is what? O, X prime, Y prime, Z. X prime, Y. Above the X axis, above the Y axis. Okay, so then this is what? Minus, minus, plus. Okay, now we'll go to the below the Y axis now. Below the Y axis is what? O, X, Y, Z. Z prime now here. Okay, Z prime. So plus, plus, minus. Okay, so these are the 8 octants we have seen. Okay, next in the part of this one, is O, X, Y prime, Z prime. Plus, minus, minus. Okay, opposite of that one now this, opposite of that one, O, X, Y, O, X prime now, O, X prime, Y, Z, Y, Z prime, minus, plus, minus. And opposite of this to this, okay, so this is what? O, X prime, Y prime, Z prime, minus, minus, minus. Okay, so these are 8 octants. These are 8 octants. There is no specific name for the octant. This is first octant, second octant. These are the octant. These are the octant. These are the 8 octant. Okay, so note that this. Now, suppose Px1, y1, z1 and Px2, y2, z2 are the points in the space. Then you know the distance formula. Distance between P1 and we'll call this is P1 and P2 is given by P1, P2. You know the distance formula in 2-dimensional geometry. So that is what? The root of x1 minus x2 bracket square plus y1 minus y2 bracket square plus z1 minus z2 bracket square. Or you may write this is what? x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. Okay. So then you know this formula. That is what? Section formula. So what is here? Suppose this is your P1, this is your P2. Suppose this point is P now here. This point P. We divide the ratio M is to N. That means what? P1, P2 as M is to N. suppose your P divide P if P divides segment P1 P2 in the ratio m is to n, then P then first internal division, okay, internal division P. So how to write this? What? P1 P2 internally in the ratio m is to n, suppose. Then what you have to do? You have to multiply m to P2 and n to P1, because it divide P1 P2 internally in the ratio m is to n. Then your P is what? You have to multiply n to P1 and m to P2 now. Okay. So I will first multiply by m x2 plus n x1 upon m plus n. Okay. So m goes to P2 now, right? Okay. So same thing here, about y2 plus n y1 upon m plus n, m z2 plus n z1 upon m plus n. Okay. So if it is external division, so P is the coordinates of P are, just write minus sign here now. So m x2 minus n x1 upon m minus n. Same rule you have to apply, m into P2 and n into P1 upon m minus n. Okay. So just cross multiply like this. Okay. So that is what? M y2 minus n y1 upon m minus n. M z2 minus n z1 upon m minus n. So if externally means what? This is your P1, this is your P1, this is your P2, and your P is here. Your P is here. So that P1 P is m and P2 P is n. Okay. So P divide the segment P1 P2 externally in the ratio m is to n. So externally in the, that means what your P1 P is m and P2 P is n. And internally division means what? The P lies on segment P1 P2. If P lies on segment P1 P2, then we are saying that P divides the segment P1 P2 internally in the ratio m is to n. If P is not on the segment P1 P2, if P is not on the segment P1 P2, but it is on the line P1 P2, then we are saying that P divides the segment P1 P2 externally in the ratio m is to n. Okay. So we need this section formula. We need also the distance formula of a point. Okay. So I hope that you understand how to determine the coordinates of any point in a space. Just we have to draw the perpendicular. Also, suppose this is what your x-axis. This is suppose y-axis now. This is your z-axis and this is your x-axis. Okay. So distance from xy plane. Distance from xy plane is z coordinate. Distance from xy plane is nothing but the z coordinate. And distance from xz plane. Distance from. Okay. So distance from xz plane is y coordinate. Is y coordinate. And distance from yz plane is x coordinate. Is x coordinate in terms of distance. The same thing here. What? Distance from x axis is nothing but a y coordinate. This is the perpendicular noted. Perpendicular distance of from xy plane. Perpendicular distance from yz plane. Perpendicular distance from xy plane. Whatever this. Okay. So nothing but this. Okay. So similarly, what in the two dimensional, you know that distance from x axis, perpendicular distance of a point from x axis is nothing but a y coordinate, and perpendicular distance of from y axis is nothing but x coordinate of that point. Same thing here on the plane in terms of the plane now. perpendicular distance of a point from xy plane is nothing but a z coordinate. Perpendicular distance of a point from xz plane is nothing but a y coordinate. And perpendicular distance from yz plane is nothing but a x coordinate. Okay. So I hope that you understand the coordinate geometry, how to find the distance between the 2 points, and how to apply the section formula. These are very important here. Okay. So for coordinate geometry in the 3 dimension. Okay. Okay. So we'll stop here.